Okay, good day. This is Mrs. Tole from Emulsion Private Tutors. Today we are looking at compound and double angles, and also we're going to look into identities. What you need to do actually to solve, to prove identities. Now, when you're looking at compound angles, for cos, with cos A minus B is equals to cos A cos B plus sin A sin B. Your cos A plus B is going to be, so you can see that the sign does change there. So when you've got plus here, you're having negative, you're having plus. But when it comes to sine, we're saying sine A minus B is equals to sine A cos B minus cos A sine B. Okay. So this expansion, where do we need them? We need them normally to simplify angles. So for example, we can say sine 70 is equals to sine 60 plus 10, and sometimes maybe are given what you call sine 10. So in that case, now it will be very much easy to use your special angle. Now, so for example, here we're given that sine 10 is equals to maybe, let's say is equals to t. Then we are asked to find sine 70. This is going to be sine in bracket 60 plus 10. So in this case, now you go on to apply what we have, the compound angle. But let's just see what we have here again is double angles as well. So sine 2A is equals to 2 sine A cos A. Then cos 2A is equals to cos. So cos 2A, you can have three ways of expressing it. You can express as cos squared A minus sine squared A. Then 2 cos A minus A, 1 minus 2 sine squared A. So now you need to understand something here. When you're looking at these answers here, this expression for 2A cos 2A, we need to understand that you must be wise on choosing which one to apply, especially when you're proving identities. We must choose which one to apply according to what we have. So it requires some thinking when you're proving identities, and also using this. So you need to know where to apply it, where not to apply it. Now, let's check here what we have here. Evaluate the following without the use of the calculator. So what we see there is actually 2 sine 22,5 cos 222,5. And as we can see is what we have there. So we're going to have sine. So what it simply means, it means that it's sine 2 in bracket 22,5. Now, 22,5, what is 22,5? 22,5 times 2, we get 45. So here we're going to have sine 45, and we know that sine 45 is a special angle. Sine 45, we have root 2 over 2. So this gives us root 2 over 2. That becomes our answer there. Can you see what we did there? So we are saying this is the reverse. So you are coming from this to to sine 2A, and what is your A? Your A here is 22,5. That's why we're saying sine 2 times that 22,5. Let's check here what we have here. We are given that 4 sine theta cos theta. We don't have any expression for this, but what can we do? We can modify it. What do we need to do? We can factorize it, if I can say, or modify. When you are having 4 is 2 times 2. So it simply means that it's 2 in a bracket 2 sine A, sine theta, cos theta. So what we did here, we express what we want now. Now we know this is sine 2 theta. So we're going to say sine 2 theta. That becomes our answer there. Now, let's check with the last part there, sine theta, cos theta. Now, when you look at sine theta, cos theta, we know that there is no, there is no expression for this. There's no, it's not a double angle, and we don't have any identity for this. So what must we do? We must modify it. We know that we need to have 2 here. So for us to have 2 here, we can't just put 2. We need to put 2 over 2, 2 over 2. So 2 over 2 is more like a 1. So you didn't do anything there. So we have got 2 sine theta cos theta. That's what we're having there. So you're having 2 over 2. In that case, we can just put it like this if it's fine. Now, what are we going to get now? We are going to get this 2 sine theta cos theta is what we know. We can have it. So it's going to be 1. So it's going to be sine 2 theta over 2. That's our answer there. So can we see what we need to do when you're modifying? You're doing what we call modification. Now, to suit what we want, we suit what we want. To suit what we want, this is just more like 1. We're adding 1. So we are not changing anything here. So when you say 2 over 2 is give you 1, that's why we're doing it. But now let's check here what we have here. Is cos 2 theta plus sine 2 theta in bracket cos 2 theta minus sine 2 theta. This is a difference of squares, difference of 2 squares. So difference of 2 squares, what do we know about difference of 2 squares? When it's like this, we know difference of 2 squares, a squared minus b squared is going to be equals to a plus b, a minus b. So this is what we're having. We're just going back to what we have. So what are we going to get here? We're going to get cos 2 theta squared minus sine 2 sine squared 2 theta. Now, when you've got sine cos squared 2 theta minus sine squared 2 theta, this is what we have. We're going to go to this identity here. What does it mean? It means that it's going to be cos 2 in bracket 2 theta. What are we going to get there? We are going to get cos 4 theta. That becomes our answer there. Then let's move on to another one here. We're saying 40 cos 40 over sine 100. But now I want you to remember this sine 100 in terms of acute angles. How are we going to get acute angle equivalent to that? We say 180 minus 100. So what do we get? We get 80. So sine 100 is the same as sine 80. So when you have got sine 80, we're going to say sine 40 times cos 40 over sine 80. Now, sine 80 is equals to 40 plus 40. So what must we do? We are going to have something like this. So let me just start it here now. We're going to have something like this. Sine 40 cos 40 over sine 40 plus 40. Can you see how we are applying now our compound angle? How we are applying the compound angle now? How we are applying it? We are applying it now. We want it to suit what we have here, because we've got 40 here, and we don't have 40 down here. So we must find a way to get to 40 there, so that we can be able to cancel it if it's possible. Now, then here, what are we going to get here? We are going to still remain with sine 40 cos 40, over. Now, sine 40 cos 40, we can express, use the double angle here. Is going to be equals to sine 40 cos 40 plus cos 40 sine 40. So in this case now, we can see that these two are the same. We can just add them. So we're going to have something like this. So let's come back here. Sine 40 cos 40 over 2, because these two are the same. It's more like x plus x. 2 sine 40 cos 40. Then sine 40 cos 40 cancels. Then we are going to have 1 over 2 as our answer. Can we see how we get to our answer now? So we need to make sure that we are able to apply this, and also this knowledge. I think if you check in Trig 2, you'll be able to understand what we're talking about here when you're expressing it into acute angle. Now let's check what you need for proving identities. Proving identities, you need to understand this. Remember, with proving identities, you can either start from the left-hand side to the right-hand side, or from left-hand side to from right-hand side to the left-hand side. So you check which one is easier for you to actually to deal with. So you're not forced always to move from left-hand side to right-hand side. So you can actually start from right hand side to prove that it's equal, it's actually identical to the left hand side. So whichever way you want. But now let's see what you need to apply here when you approach these questions. The first thing that you need to note is that tan, use the identities, tan, express it as sine over cos. Then whenever you are going to have sine squared theta plus cos squared theta is equal to 1. So remember, this is actually going both ways. It has to favor what you want, please guys. It has to favor what you want. Again, even this one here. So it needs to favor what you want. So if you find that, oh, in my answer, they've got sine squared theta, I need to have that. But where can I have it? But I have 1. So what should you do? You express 1 as sine squared theta plus cos squared theta. Then if you are to have what you call this, you are left with this now, and the answer should be tan theta. Now you need to go back to what you call to tan theta. So that's how it is. So you must make sure that you deal with these identities as well. But now another thing again is that you use double and compound angles. The double angle sine 2 theta cos 2 theta, the sine a plus theta, cos a plus theta as well. Then the major thing that you must also understand here is that addition and subtraction of fractions. So you must be able to add and subtract fractions by finding the LCD, the lowest common denominator, and simplify it. Then another thing, major thing again, is that you need to learn to factorize. Factorizing. Now, when you're factorizing, expressing it, whatever expression that you're having into factors, now take out the highest common factor. Take out the highest common factor and see what you're left with inside. Then difference of 2 squares. So difference of 2 squares, it applies a lot as well. Then trinomials, quadratic equations. It can come in form of quadratic equation. Then you need to actually to simplify it, to express it as factors. That's what we call trinomials. Then grouping as well. You must group like terms and see what you can come up with. Because remember this, you don't have an exact way to say we're going to solve like this, but you have to think along these lines. That's why we are telling you this. We need to think along these lines for you to get to the answer. Now, again, something that you need to sum and difference of 2 cubes. Some of you don't know this. Difference of 2 cubes. So whenever you're left with sine cubed, cos cubed, and you're like, what should I do here? Now, these are the what you call just like difference of 2 squares here, we say a squared minus b squared, a plus b, a minus b. The same applies here. When you are having something like this, a cubed plus b cubed is equals to a plus b in bracket, a cubed, a squared minus ab plus b squared. These are just expressions that are there already. You don't need to prove anything in this case. So what you need to do when you are left with sine cubed plus or sine cubed minus cos cubed, you need to express it in this form. Okay, let me just express one for you. Let's say sine cubed theta minus cos cubed theta. This is equals to sine theta plus cos theta in bracket sine squared theta plus, so what do we have here? Minus, sorry, it has to be minus there. Can I have my rubber? Follows the sign there. Then you are going to have plus sine theta cos theta plus cos squared theta. That's what we're going to have here. That's what we have there. Okay, so that's what you must understand. So here is our expression for what we call sine cubed theta minus cos cubed theta. Because now you find that in the answer, you might have this expression already, but the answer must be left as sine theta minus cos theta. Then you know that this one is going to cancel. But now let's check into what is it. Another thing that you must understand as well, modifying of your expression to suit what you want. You modify to suit what you want. For example, sine theta, when you left sine theta, you can have tan theta cos theta. How did you get there? Now, it's actually interesting because sine theta, you multiply it with cos theta over cos theta. Now, cos theta over cos theta is just 1. You're not doing anything. Just like you're multiplying with 1 here. So what are we left with now? This is now sine over cos. Sine over cos is equal to tan theta. Then you're left with cos theta here. Then tan theta, cos theta. The same applies here. If you are to come back here, this what called these two will cancel. and you're left with sine theta. So that's what you need to understand there. So now let's check into look into some of the examples that I've put here so that we can do together. Now, cos to the power 4 minus sine to the power 4 is equals to cos 2 theta. Now, what do we need to know this? This is a difference of two squares, guys. Difference of two squares. Don't forget this. So what do we know? We know that it's gonna be cos 2 theta cos squared theta minus sine squared theta in bracket, open another bracket, cos squared theta plus sine squared theta. Some of you are saying, where are you getting this squared? Because this is more like we are saying it's cos squared theta in bracket, we squared minus sine squared theta, which we are also squaring it. And can you check here what we are having? Can you check what we're having? This is our A. So our A is more like it's just cos squared theta. That's why we are saying this. So 2 times 2 is going to give us 4. That's what we're having here. That's why I'm saying here is cos squared theta minus sine squared theta. But what do we know about cos squared theta plus sine squared theta? This is equals to 1, identity. This is identity. Cos squared theta plus sine squared theta is equals to what? 1. We know this. So this one is going to give us 1. But what is cos squared theta minus sine squared theta? From what we know, it's also one of the expression for cos 2 theta. So it's just going to be cos 2 theta times 1, which is going to be equals to cos 2 theta. That's what we have there. That's our answer there. Okay. Let's check here. Another thing, another expression that we need to, another question that we need to tackle here. Now we are given that cos 2 theta over cos minus theta minus sine theta is equals to cos plus theta. But what do we know about this? So when you are given this, you must think along the lines that, all right, now I am having this. This is one of what? We're going to choose wisely here. We're going to take cos squared theta minus sine squared theta over, so we're writing left hand side. I didn't indicate that. You need to indicate which side are you coming from. So it's going to be left LHS. You're proving LHS. Now here is going to be cos theta minus sine theta. But now what is the difference of two squares? Guys, remember cos theta plus cos sine theta in bracket, cos theta minus sine theta, then O over cos theta minus sine theta. Then here what we have here, this one here will cancel with what? With what we have here. Then we are left with cos theta plus sine theta. This is our answer that we want. Okay? This is the answer that we are looking for. Now let's check again this let's attempt this one again. But now can you see what we're having? Tan theta. What do you remember, guys? Remember left hand side. Remember here we need to express it as sine over cos. So sine A over cos A plus cos A over sine A. But now what do we know? We know that sine, when we are adding, we take the common denominators, multiply the common denominators. That's our lowest common denominator. We have got cos A sine A. You must learn how to add, guys. You take here, then you say cos into this, you are going to get sine. So you're going to get what? Sine A times sine A, that is already there. Then sine into this, sine theta into, what is it? Sine theta into cos A sine theta. We are going to have cos theta plus cos theta, cos A sine cos A. Then this one is going to give us sine squared A plus cos squared A over cos A sine A. But can you see something interesting here? Something interesting here, we are saying this is our identity that we know. We're going to just have in place with 1. So we are left with 1 over cos A sine A. But again, we are not yet having our answer here. We need to prove this. Sine 2A, what do we know about sine 2A? Sine 2A, we know that sine 2A is 2 sine A cos A. So what is left here? What do we need here to have this? We need 2. Where can we get 2? Simple. We need our 2. So we're going to say 2 over 2 cos, we are modifying cos A sine A. Now, when you have this 2 over 2, it gives us 1. So we are not worried. So it's going to give us 2 down here. It's going to be equal to 2 over sine 2A. Then that's our final answer. So guys, modification is very much important. You need to modify your things. And when you're modifying, you're just adding 1. This is just 1. Remember, we didn't have it, but we want to get up to there. So you must link. There's a little bit of thinking there that you need to do. Now, let's check here what we are having here. We are having what? We are having sine A, 1 minus sine A, or tan A, 1 over tan A. We need to prove this. Now, let's check left-hand side and see if we can do that. Now, what do we know tan? It means expressed as what? As cos, as sine over cos. So we're going to say 1 minus sine A over cos A all over 1 plus sine A over cos A. Hear me now. Hear me now. What we are going to deal with here, we're going to deal with these guys separately. So you are going to add what's on top. And what's on top here, what is your common denominator? Is cos A. So before you do that, you've got that big, what is it? You have to underline there. This one representing, separating the 2 here. Now, when you've got cos A, you're going to say now 1 into cos A, we get cos A. So it's going to be cos A. Then cos A into this, you're going to get 1. So you're going to say 1 times sine A minus sine A over. Then here, what is our common? Like what is common here again is cos. So we're going to have cos. Okay. 1 into cos A, we get cos A. It's going to be cos A. Then this one is going to give us plus sine A. So what we are simply having now, this is what we are having here. And how do you deal with that? How do we deal with that? We need this. So what must we do now? We need to take, so this one is more like when you're saying A over B divided by C over D. So this is the same as A over B. You interchange this. You swap this times, then you put a multiplication sign D over C times D over C. Can you see what we're saying here? So this one here, you must remember this. So what do we need to do now? We're going to say this is dividing this. So what must we do? It must be cos A minus sine A over cos A. Okay, we must multiply it with cos A over cos A plus sine A. That's what we're going to have there. Then when we have this, this is common, we're going to cancel. These two are going to cancel. And what we are left with, we are left with cos A minus sine A. Then you're having cos A plus sine A. So what must we do here? What is lacking here? What is lacking here is that we need to multiply. We need to multiply these two. We need to multiply these two. And how do we multiply these two? We know that for us to get that, we need to have, a difference of 2 squares. Because cos 2A, we're going to have something like cos squared A minus sine squared A. But we need this. So we're going to say cos A plus cos A over cos A plus cos A times cos A minus sine A over, this is what we are going to bring down here, cos A plus sine A. So already what we have here, we are going to have on top here, difference of 2 squared is going to be cos squared A minus sine squared A over, when you multiply these two, cos A plus sine A, sorry here, plus sine sorry about this, plus sine A, we are going to have cos A times cos A, we get cos A squared A, then cos A times sine A, we're going to have plus cos A sine A, then sine A times cos A, we're going to say plus sine A cos A, then sine A times sine A, we're going to get plus sine squared A. Then these two here, these two, when we take them, when we cos A squared plus sine A squared, we get 1. So we're going to bring out, so this one on top, sorry, before we go there, cos squared A minus sine squared A is giving us what? Identical for cos 2A. So we're going to write, that's our answer there on top. This is going to be cos 2A on top. Then what we have, this one is going to give us 1. Then plus, then now what are we having here? We are having cos A, cos A, sine A plus sine A cos A. This is the same, this is going to give us 2 sine A cos A. Then 2 sine A cos A is identity for double angle sine 2A. Then our final answer is going to be cos 2A over 1 plus, sorry, sine 2A. Then proved. You have proved our what called our identity. So I think you've mastered how you need to think, how you need to see identities. When you're proving identities, I think you've seen now what you need to worry about. That's what you need to worry about. You need to worry about modifying, you need to worry about the identities, you need to worry about addition, being able to add. So addition, guys, you need to be able to add. You need to be able to add. For example, here, A over B plus C over D. We know that the common here will be B, D. That will be our common denominator. Then B into this, into B, D, we are going to get D. So it's going to be DA, then D into BD, you're going to get B, then it's going to be plus BC. Then that's what we are going to have there. So you must remember, I'm just doing this for you guys to understand very well what's actually going on. Okay. So I hope this is helpful. Thank you guys. Until next time.